The Android app framework works around the Java programming language, and specifically, starting with Java 7, Android uses a customized version of OpenJDK, an open-source implementation of Java from Oracle. Prior to Android 7, Android used a customized version of Java that was descended from another toolkit. But the way you program with Java in Android has not changed significantly. In Android, all Java 5 and 6 syntax is supported, and most Java 7 syntax works as well. If you choose, you can configure a project to use what's known as the Jack compiler, which is part of a toolchain named Jack and Jill. If you turn on the Jack compiler, you'll then be able to use a lot of Java 8 syntax, including lambda expressions and method references. But that doesn't mean everything in Java 7 and Java 8 is available to you. For example, not all Java APIs are implemented in the Android SDK. To find out whether a particular API is available, look at the Android documentation. Here's a listing of some Java syntax that works and doesn't work. The diamond operator allows you to reduce code with generic typing, so that, for example, with a collection, you need to declare the type of the items that are being managed by the collection in the declaration, but you don't need to redeclare it in the assignment. Another Java 7 improvement that does work with Android is the switch statement with string-based values. You can also use multi-catch clauses and underscores in numeric literals. But there are some things in Java syntax that don't work across the board. The try with resources syntax, which allows you to automatically close objects that implement an interface named closable, can only be used in an app if the minimum SDK is set to API 19 or greater. If you want to target older versions of Android, you just can't use that syntax. And there's an annotation named safe var args in Java 7 that's not a part of Android because the required dependent class just isn't implemented. Many of Java's standard APIs are implemented in the Android SDK. For example, everything in java.lang is there, and most everything in Java I/O and NIO, Java Math, Java.net, and so on are all a part of the Android SDK. But again, this doesn't mean everything is available. You just need to look at the docs to find out whether something is available in Android. The Android SDK also includes many custom APIs. These are features that are in custom packages that typically start with Android and end with a description of what that package does. So, for example, Android.app, Android.database, Android.net, and so on include classes and interfaces that aren't available in general Java, but are available for Android. To learn what's available, look at the API reference at this URL. When you build an app in Android Studio or from the command line, there are two possible build processes that you can use. The default build process, as of October 2016, is called the legacy process, and here's how it works. You start off with a set of Java files, either source code files or files that have been pre-compiled to bytecode in .class files. These are processed through the standard Java-C compiler, which turns these files into class files, Java bytecode. From there, optionally, you can transform those classes using a tool called ProGuard. The ProGuard tool minimizes and obfuscates the bytecode so that it's harder to decompile and is smaller. After ProGuard does its thing, you still have .class files, but they'll be smaller than the original files. Then, these files are taken through a tool called DEX, which turns the files into DEX-based bytecode. DEX bytecode is universal bytecode for Android, and this is what's actually packaged in the application when it's deployed to devices through the App Store. Now, if you configure your project to use the Jack compiler to allow you to use, for example, Java 8-based syntax, the process of building the app is a little bit different. You once again start off with your Java files, either source code files or pre-compiled class files. These are processed through the Jack compiler, which goes directly to the DEX bytecode. The Jack compiler does all of the tasks that Java-C and ProGuard were used for in the legacy process. It does the compilation and optionally can minimize and obfuscate the code. When you use the Jack compiler, you'll see that your compilation process is a little bit faster, and you'll be able to use a lot more Java syntax than before. There's one downside to using the Jack compiler that I know of at this point, and that's that in Android Studio there's a great tool called Instant Run, which can deploy parts of an application to a testing device. Projects that are built with the Jack compiler don't support Instant Run at this point, so especially when working with larger applications, they'll take a lot longer to build and deploy during the coding and testing process. If you're willing to put up with that, it's worth going over to the Jack compiler to give yourself more flexibility in coding style. Once the DEX code is delivered to the device, what happens then depends on which version of Android is being run. The DEX bytecode has to be translated to machine code on the device. Android can run on a variety of CPUs, from ARMs to Intel chips and so on. And so the machine code that's going to be really fast at runtime has to be built by tools that are on that device. What changes from one Android version to another is when that DEX code is created. On the Dalvik runtime in Android 4.4 and prior, DEX bytecode is built as the application is running, each time a feature is used for the first time. This process is called just-in-time or JIT compilation. Starting with the Android runtime in Android 5, the process moved to ahead-of-time compilation. And in Android 5 and 6, this process happened when the app was installed or upgraded, or when the operating system was upgraded. In Android 7, Nougat, this process has been changed yet again. Now, each application will be compiled ahead of time the first time it's started up. And that means when you upgrade your device going to a more recent version of Android, it reduces the amount of time it takes. All of the applications don't all have to be recompiled, significantly delaying the amount of time before you can actually use the device. So that's how Java is used in Android. Again, which aspect of Java you'll be able to use depends on which version of Android you're using and which version of Android Studio you're using, and whether you've configured your project to work with the new Jack and Jill toolchain and the Jack compiler.